We want to talk about understanding speed and how to take a rate and convert it into a speed. So in this problem, we have Jamal ran 6 miles in 30 minutes. Which expression shows how to correctly determine his speed in miles per hour? The question is very revealing in how you should set up your division problem. We want that's miles per minute, 6 miles in 30 minutes. What is his speed in miles per 1 minute? So we're basically taking 6 miles in 30 minutes, and we want to set that equal to how many in 1 minute. So we can see in the denominator, we are going from 30 to 1, which means we're dividing by 30. So what we do to the denominator, we need to do to the numerator. And we also see miles per minute, which means we want to take the number of miles and divide by the number of minutes spent running there. So when we divide 6 by 30, we have to add a decimal and a 0 because 30 does not divide into 6. And then we divide 30 into 60. 30 times 2 is 60 with a remainder of 0. So we see he traveled 0.2 or 2/10 of a mile every minute. The fastest train in Japan traveled 75 kilometers in 0.25 hours. What is the speed in kilometers per hour? So we want to divide kilometers divided by the number of hours. 75 divided by 0.25 or 25 hundredths. When you have a decimal that you're dividing by, remember your rules there. You need to move your decimal to make that a whole number, and however many times you moved the decimal in the divisor, you have to move the decimal in the dividend. Since we don't see a decimal in 75, we know it's at the end, so we're going to move the decimal 2 times, filling in 2 zeros. So an equivalent problem is 7,500 divided by 25. 25 goes into 75 3 times. 25, bring down a 0. 25 goes into 0 0 times. Bring down the next 0. 25 goes into 0 0 times. So that is 300 kilometers every 1 hour. Another way we could have thought of that is 75 kilometers in 0.25 hours. How would we take that and make an equivalent fraction? Per hour is the unit 1 hour. Per is the division line, 1 hour. And what do we multiply 0.25 by to get 1? We multiply by 4, and what we do to the denominator, we have to do to the numerator. 75 times 4 is 300. So 2 strategies there for converting that speed to a speed per 1 unit. Amir ran the first 200-meter leg of the relay race with a speed of 8,260 millimeters per second. Ryder ran the last 200-meter leg with an average of 930 centimeters per 1 second. Who ran the face faster, and how much faster was that person's speed to the nearest meters per second? So I want to have my answer in meters per second. And neither of these are in meters per second, but they're all in a unit rate for 1 second. So I need to convert millimeters and centimeters. I need to figure out how many meters in 1 second for each one of these. So I'm going to have to multiply by a unit rate that will get me from millimeters to meters, and that will get me from centimeters to meters. The way I like to convert in the metric system is I use the acronym King Henry died by drinking chocolate milk. This stands for kilo, hecto, deca, the base unit, which the base unit here is a meter. Base is what you're measuring. Meter measures length, gram measures weight, liter measures volume. Then we have deci, centi, and millimeter. So for both of these, a meter is larger than a millimeter and a centimeter. I'm going to use this to determine how many millimeters are in a meter. The way I do that is I put a 1 to the measurement that is on the left-hand side. So again, we're trying to get meters and cancel millimeters. So millimeters needs to be on the bottom so that it cancels, but I have to know how many millimeters are in a meter. A meter is bigger, so 1 meter. Now fill in zeros until I get to millimeter, and that is 3. So 1,000 millimeters is equal to 1 meter. Do the same thing for centimeters, but you don't need 3 zeros because centimeters is right here. 1 meter is equal to 100 centimeters. So 100 centimeters goes on the bottom so that centimeters will cancel, and that is equal to 1 minute. So we had to use what we knew from past lessons to be able to convert so that we could compare both of our answers in meters per second. So this would be 8,260 divided by 1,000, which is 8.26. This would be 930 divided by 100, which is 9.3. We had Amir and Ryder. Ryder ran faster, and if we subtract, we see that Ryder ran 1.04 meters per second faster than Amir, because 9.3 is 1.04 greater than 8.26.